G'day everyone, in this video we're going to be looking at how to differentiate polynomial functions. So just having a bit of a look, I've got some rules here and I've actually highlighted what is relevant to each type of question that we're going to be looking at here. So we'll just get straight into it. So for our first one, we've got fx is equal to x to the power of 12. So you can see I've highlighted in blue up the top here that fx is equal to xn. So that's what we've got here, x to the power of 12, where n is 12. F dash x, so our derivative, is going to be nx and then n to the minus 1. So that just means we multiply whatever's out the front of the x and then we drop the power down by 1. So hopefully you can see in this, and I'm just going to write out our rule. Our rule here. So we've got, this is going to be nx n minus 1. So it makes f dash x is equal to 12x to the power of 11. So we don't need to do all the stuff with first derivatives. You can just follow these rules and easily differentiate these equations. So we'll go on to the second one here. So this here is a linear function, and there's a rule here for this, but you can treat it like the sum that we're going to do for the next one as well, and understand that the constant goes to 0. But a linear function, fx is equal to mx plus c, then f dash x is just going to equal to m. So it's just going to equal to m, so we can just write that out. Okay, and if you do it like the sum of the next one, I'll just show you, it actually drops down a power, so it becomes, this becomes, and I'll just show you what happens. So we get 5x to the power of 0, or 5 times 1 because it's 1. And then we actually use the constant function up here for the second one. So if it's equal to c, then it's equal to 0. So this becomes 5x to the power of 0, 5x to the power of 0 plus 0, and x to the power of 0 is 1, so it becomes 5 times 1 plus 0, which is equal to 5. So that's why that rule actually works there for the linear function. So finally we'll go into our sum, okay, where we're plussing two polynomials together. So here we've got, you can just split this up and differentiate them separately. That's essentially all this rule states. So you can differentiate the 10x to the power of 5 and then differentiate the 3x to the power of 4 and plus them together at the end, and that will be your answer. So we'll do that now. We've got f dash x. So this becomes 5 times 10 because it's 10 times x. So I'm just going to write 10 times, I might need a little bit more room here. Just do that. So this becomes 10 times 5, and then x to the power of 4 because we drop it down a power, then plus 3 times 4 x, and then drop it down a power to 3. Okay? So this is often a common mistake. Some people forget to multiply out the front. So just remember that you are doing that. So this becomes 50x to the power of 4 plus 12x to the power of 3. And that is it. So just remember, always have these rules handy, especially when you're starting out, and hopefully you get enough practice that you can do this really without thinking. That's the aim that you want to have, especially going and completing these a lot easier, and it just makes everything else a lot easier when you do need to use differentiate. So hopefully this helps, and good luck.